Hi viewers, this is Sri Ramulu. So today's topic is transverse vibrations of a bar free at one end and fixed at other end. See the diagram of this. So bar, so let it is a bar. So having the two ends, first end generally we denote at x is equals to 0 and second end is at x is equals to L. That means it indicates L from here to here length is L. That is the meaning of this. Okay. So let this end, one end is free, right, and other end is fixed. Okay, so let it is like this end is fixed to the support, rigid support, like this. Now see, this end is free. So for this, if you apply the boundary conditions, then how much it forms frequencies, so that frequency we can calculate using this concept, and at the end of frequency formula also we get. See what is that. Okay, so when the bar is fixed at one end and free at other end, the following boundary conditions valid. So what are the boundary condition? Y equals 0 and dou y by dou x is 0. So these two are 0 where at the first end, means at x equals 0, let that end is fixed. Okay, so this like this end, so this end is fixed, but this end is free. For free end, so at what distance? At x equals to L distance, free end, then dou square y by dou x square is equals to and is equals 0 and dou cube y by dou x cube is equals 0 at what, where, at x equals to L. The general formula is there. General solution of transverse wave equation is y is equals to cos omega t plus theta into a cos h omega by v x plus b sin h omega by v x plus c cos omega by v x plus d sin omega by v x. Okay, first two are hyperbolic function and remaining two are normal function. So cos, sin, like this. So here the first boundary, by using first boundary what we can calculate the relation between a b c d only. So this relation we get. So for this, what I am doing, I am going to apply the first boundary condition. So what is that? This relation I am going to apply. Okay, y is equals to 0 where at x is equals to 0. So substitute in the in the equation 1 directly. Y 0 at x equals 0, y 0, this is x 0, x 0, x 0, x 0. Okay, so we know that, so 0 into something is always 0, that means it is cos 0, sin 0, cos 0, sin 0. We know cos 0 is 1, cos hyperbolic 0 is 1, simply cos 0 is 1, but sin hyperbolic 0 0 and sin 0 0. So like this. So these values I am going to apply here. So it is 1, it is 1. So a plus c only we get, and our remaining all are zeros. So from this c is equals to minus a. Next, if you want to apply the first BC, second formula from first BC, this combination over next for this combination. Okay, for this combination what we have to do, for y one time we have to differentiate. So it is a y equation 1. So differentiate equation 1. Differentiate equation 1 means once only, one time. We know one time what you get when you differentiate, this come outside one time, came outside, and cos h sin h becomes cos h cos. So here cos x is simply minus sign. In hyperbolic you cannot get any minus values, but in normal trigonal functions you get cos becomes sin, it a differentiation, sin differentiation plus cos. Okay, so like this we got. Now apply the boundary conditions. What is the boundary conditions? So first boundary, in the first boundary condition, second formula is what? This is dou y by dou x 0 at x equals 0. Okay, so that is why here 0 0 and x is 0 means here 0. Everywhere wherever we have the x value, there it is 0. And then just know what I said above, sin function sin 0 0, cos 0 is 1. Here it is 0 and this is 0, but here it is cos, that is why 1, it is also cos, that's why 1 into d only, 1 into b only. So here b plus d we got. From this d is equals to minus b, right? And here what we got, c value as minus a and d value as minus b. Substitute these two values in the equation 1. So if you substitute in the equation 1, then what you get, in the place of b, in the place of c minus a, in the place of d minus b. Okay, in the place of d minus b. Let it is equation 3. Okay, so next if you have to apply the second bc, see second bc is here also we have the two combinations. One combination in second bc, this is dou square y by dou x is equals to 0 at x is equals to l. Next combination is this one, dou cube y by dou x cube is equals to 0 at x is equals to l. So let me use this one, means you have to differentiate y twice and later it is thrice. It is thrice for later, so that is really later. Okay, differentiating equation 3 only. So to this equation, after substituting the values of cd in the equation 1, then we got the equation 3 it is, and differentiate it twice. So twice, cos differentiate one time, sine. But here how many times you differentiate, that much of time it comes outside, so and become it square. So already I have taken common to it outside. And now see, cos differentiation is sine one time, again sine differentiation is cos other time. So see, this is right. So sorry, here cos we have, cos differentiation is one time, sine one time, sine differentiation second time, cos. Next similarly sine, second one, sine differentiation first time is, sine differentiation first time is what, cos. Cos differentiation second time is sine, no minus. Why? It is hyperbolic function. Cos h differentiation, sine h differentiation, cos h only. So how many times you differentiate it, you cannot get any minus values, negative values in hyperbolic function. That is, you must keep in mind. And next here, cos differentiation one time is, first time is sine, sine differentiation second time is minus cos. Already have the minus, minus plus. Next, sine differentiation one time is cos, cos differentiation second time is minus sine. So already have the minus, it become plus. Okay, like this we got. And now differentiate, now substitute the boundary conditions. It is not first boundary condition, second boundary condition it is. So sorry for this. So make it as second boundary condition. Dou square y by dou x square is 0 at x is equals to l. So this value is 0, and here l. So that like this, here. Okay, bring these two quantities this side, these two become 0. Everybody know from above equations also, that is we got. Okay, here also I didn't explain, but you must understand here. So these two terms, if you bring this side, 0. Okay, similarly here also, if you bring this single term this side, this cos of omega t this side, it becomes 0. So I didn't explain it there. Now it is like this. Okay, so these two terms come this side and become 0. Now this bracket only remains. So this is, and next take common factors only. What common factor? A common. So wherever you have the a here and here, so both are cos h cos only, and b common, it is sine. So first sine we get. Let it is and bring here, this is this side. Now it is a plus. If you bring this side, it becomes minus. So let it is equation number 4. Okay, again differentiate, not equation 2, it is equation 3 only. Okay, see here, equation 3. Again differentiate equation 3. How many times? Thrice now. Okay, so thrice differentiation. So thrice differentiation. Okay, it is okay, see here, one time already it is, see, let me differentiate simply this one only. It is already 2 times differentiated. If you differentiate it once time, then it becomes 3 times. So it becomes like this only. Okay, and now for one more time, first third time, Again omega by v come outside, already square is there, it become cube here. Okay, cos differentiation 1 times sine, already 2 times is there. If you do one more time, it becomes 3 times cube, it become cube. Cos sine, sine cos, cos differentiation minus sine. Okay, sine differentiation only simply cos, here cos, see it is cos, like this. Now apply the boundary condition, second combination it is, boundary in boundary condition, second combination. So it's this second combination. Okay, so this term is 0 and here L L L L, so L L, here also L L. Okay, now bring this factor this side, it becomes 0, so then bracket will remains there only. Now take common factor a, here a and here a, it is a plus, it is minus. Okay, and next take common factor b, here we have and here you have, right, b is taken outside, it is both are cos value is taken. Now keep the sign coefficient at this side only and bring this b coefficient that side. Now it is plus, if you bring it this side, it become minus, and let it is equation 5. Now divide equation 4 by 5, it is a fourth equation and this is a fifth equation. So from these two equation what we get, minus v gets cancelled, a gets cancelled, then this is things, and a cross multiplying. Cross multiplication means multiply these two things and these two things, multiply these two things and write left side, and multiply these two things and write right side only. Okay, like this written, left side and right side. And see these two factors are same, becomes, so that is by whole square. And see these two factors are not same, means here minus you have, here you have plus, it is a plus b form, it is it is a minus b, it is a plus b. Then what is this, it is a square minus b square form only, so that is fine. But here cos same, whatever factor you have, the same factor it is, so that is why it is squared. Now expand this one, a square plus b square plus 2ab 2ab, and it is written as it is copy pasted. Now write it is here and bring this sign nearer to it. Okay, so it is a plus term, if you bring this side, it minus. And next write it is here this side only and bring this is a 2 near to this one. Okay, now it is minus, if you come bring this side, it become plus. Okay, these two factors written as it is only. And we know that cos in hyperbolic function, cos h, so we know in hyperbolic function cos h square theta minus sin h square theta is equals to 1 in hyperbolic function. But in normal function, that is we know cos square theta plus sin square theta is equals to 1, but in hyperbolic minus, so it gives 1, this gives 1, in between them plus you have, so that's why you have plus. And these two factor as it is written is equals to 0. Why? These two things already brought this side, so that is why this side 0. Now 1 plus 1, it is a plus 2, next again one more plus 2 is there. Okay, bring this plus to this side, it become minus 2, 2 gets cancelled, minus 1 is there, and its transcendental form, it is called transcendental form, in means in cot, cos, in cot or sine, this is the form. And see here, so from this we can get in tan and cot form, like this only, cos, it is hyperbolic for hyperbolic, for normal. And the graph, if you draw the graph between these two things, the graph for cot omega L by 2v and tan h omega L by 2v intersect, mean they coincide, where intersect at certain values of these, which gives a vibrational frequencies. These are, what are those? 1.194 pi by 4, comma 2.988 pi by 4, comma 5 pi by 4, comma 7 pi by 4, comma 9 pi by 4, like this we get. Alright, therefore see here, so where at what values, at what values, for these values, means for this value, so when it is equals to this one intersection, then at this point these two waves may intersect, at this point these two waves intersects at this point, these two waves intersect like this. Okay, so I'm writing general formula. So this is equals to this is equals to this. Okay, but we know the v value as under root omega ck. V value under root omega ck is equals to this one. Taken here, the pi is common. Why? Because pi is multiplied to all. Now squaring on both sides, then what you get? See here, if we square to this one, omega square L square upside 2 becomes 4, and for this square for square root cancelled. Okay, here pi square by 4 square, and all factors are squared. Okay, all factors squared. Now see here, for omega square 1 omega will be there. For 4 1 4 will get cancelled, and okay, now remaining omega L square by ck we get. But from this omega is equals to bring ck and L square this side, ck goes upside and L square comes downside. Yes, that is also done here. Okay, but we know the omega value like this, then pi 1 pi gets cancelled, one more pi is there, and bring this to this side, already 4 is there, it becomes 8 only without changing anything. Okay, now in general formula, so for f I am writing simply fn, it is general. Okay, if n is equals to 1 means take the first factor. Okay, so if n is equals to 1, but first factor into this one. If n is equals to 2, it gives f2 value. That means this into this, it is second vibrational frequency, or it is, this is a called fundamental frequency. And combination multiplication of these two things means when n is equals to 2 means second thing we have to take. So second thing is f2 is equals to what? It is pi ck by 8 L square into this factor 2.988 whole square. It is called first overtone. Okay, and multiplication of these two things called second overtone, and multiplication of next thing is called third overtone. So like this we get a number of overtones and their frequencies like this. Okay friends,